Welcome back. Today we are taking a deep dive into ICM Architect, a fascinating Claude skill based on the interpretable context methodology paper. Instead of relying on complex Python orchestration frameworks, heavy agents, or brittle multi-agent runtimes, ICM Architect turns your simple folder structure into a complete agent architecture. By organizing your files into numbered stages, catalog routing, and clear markdown contracts, one single AI model can navigate and execute massive multi-step workflows. Let's explore how this skill works and how you can use folder structures as full agent architectures.
Let's take a look at the official README for ICM Architect. The core vision behind ICM is replacing orchestration code with intuitive physical structure. Numbered folders dictate sequencing, file hierarchy manages context scoping, and simple markdown files maintain persistent state. Instead of juggling complex state graphs in code, your AI agent acts like a librarian walking through a physical library, finding the exact catalog and documents required at each step. This makes agentic systems completely interpretable to humans while cutting down agent coordination overhead.
ICM Architect operates in two primary modes to transform how you structure agentic work. First is build mode, where it takes your raw ideas or procedural requirements, extracts execution stages, and builds a clean workspace using one of 5 battle-tested topological forms. Second is restructure mode, which audits an existing repository, vault, or messy folder system. It classifies every file as a catalog, contract, factory, product, or dead weight, giving you an automated migration plan to upgrade your project into a high-performance agentic workspace.
Here in skill.md, we see the main instructions driving the Claude skill. It outlines the core invariants and core philosophy behind ICM. Every single folder in an ICM workspace serves a dedicated structural role. Notice how the skill enforces the walk test. Any agent starting fresh with zero past memory must be able to orient itself, complete its assignment, and record status purely from the local folder files. Skill.md dictates how Claude evaluates your project needs, chooses between pipeline architectures, and guarantees deterministic execution without extra middleware.
The paper behind ICM introduces 5 fundamental forms that suit almost any real-world workflow. The pipeline structure handles linear, assembly line tasks with sequential stages. The umbrella form manages portfolios of subpipelines. The record library categorizes persistent client, user, or session state. The knowledge bundle provides a navigable brain with hierarchical context indexing. Finally, the context map maps complex organizations as structured graph nodes. Best of all, these forms can compose and recurse infinitely.
Examining references/core.md reveals the core architectural rules, the 5 principles, the 5-layer hierarchy, and strict token discipline. ICM minimizes LLM token waste by isolating context strictly inside localized files. Instead of stuffing thousands of tokens into a giant system prompt, context is tiered into specific layers: routing, global standards, stage contracts, execution state, and output products. This guarantees that agents only load the exact context needed for their current subtask. In references/forms.md, the framework details exact skeletons, valid structural moves, and key failure modes for each form. For example, in a pipeline form, each stage folder contains a context.md contract defining inputs, outputs, and validation rules. If an agent fails a stage, the output file remains uncommitted or flagged with an explicit error state, enabling seamless human inspection or quick recovery without rerunning the entire multi-agent loop. Let's check the starter template assets, starting with Claude.md. This template serves as the root catalog and operational rulebook for Claude inside an ICM workspace. It instructs the model on how to navigate the folder hierarchy, where to look for stage contracts, and how to maintain token discipline during task execution. By standardizing root guidelines across workspaces, any Claude instance instantly understands how to interact with the repository. Next is the stage-context.md template. This file acts as the explicit contract for a specific stage within a pipeline. It defines preconditions, execution steps, expected schemas, and postconditions. By enforcing rigid contracts at every stage boundary, ICM guarantees high reliability. Human operators can open any stage directory at any moment, read the context file, and immediately see what went wrong or what step comes next without debugging complex trace logs.
ICM Architect represents a huge step forward in making AI agent architectures interpretable, deterministic, and modular. By using folder structure as agent topology, you get total visibility into your agentic systems. You can install ICM Architect into your Claude Skills directory today or run it inside Claude Code. Check out the repository on GitHub, start the project, and start building transparent AI workflows. Don't forget to like and subscribe for more deep dives into cutting-edge AI skills.